and then solve the third question. Another session over there. Go back to the notepad. Oh yeah, so you selected, copy that, back to MATLAB, paste that in. Yeah, so this is asking us to to compute the fast Fourier transform of a signal. So what this is the fast Fourier transform is basically like a formula that takes a signal in the time domain and then converts it to the Laplace domain, blah blah blah. You can go and learn about that later. So basically, it's a function that takes an input and then gives you an output. That's what we have to know for now. I think it's something we're supposed to learn, but we didn't learn. So maybe we'll find time to learn. So what we will do first is to create a signal. In this case, they didn't give us a signal, right? So we'll create our own signal. And what a signal needs, think about maybe a sine wave, right? So what a signal needs is maybe some discrete value. So let's say time, just because we are using, just because it's a fast Fourier calculation. Let's say we are in the time domain and we want, let's say, I like using linspace, right? To generate values between the time one and then let's start from 0 to 1 second, and then let's say we want 100 values between these two. Let's separate that, so that will be our time, right? Then the next thing that the signal needs is a frequency. So let's say frequency f is equal to maybe I don't know 10 hertz or 10 gigahertz, whatever one you want to choose. Then now the signal itself, right? We must write a function for the signal, and that will be equal to sine. We are using a sine wave, right? Or if you like, in fact, let's use a regular FM wave, right? So I think that's A sine, A being the amplitude. So we have times 10 times sine 2 pi ft, right? So 2 pi times f plus 6 times f times t, right? 2 pi ft. So that should give you, I think we should suppress that as well. So now we've created our signal. But first of all, let's just take a look at what our signal looks like. Let's run that. And make sure this is a command window to see. Oh, okay, we have our signal right here. Why is it? Oh, sorry. I run everything instead of just running this session. Right? Remember, we have a session here, so we can just like close that. That's it. Okay, I close it. So we can just let me close this thing so that you can see. We can just run the code in this session instead of the entire code, right? So let's just run it for that session. And when you come here, you can see our 100 values for the signal that we just created, right? So let's suppress that signal because that's not the output we are trying to get. What we want is the fast Fourier transform. And to do that, let's give a name. So the fast, am I spelling it wrong? The fast Fourier transform. Okay, that's a bit lengthy, right? Well, let's keep it like it. Is equal, and to compute the fast Fourier transform, is simply FFT, right, of the signal. That's just it. It's not any big thing. It's just FFT of the signal. So now if we run this, right, and then go into the, oh, I ran everything again. Yeah. So let's go and clear the command window. I keep forgetting to run the session. So if we just run the session, right, and come here, you can see this is the fast Fourier transform is equal to these values, right? So that's just basically yes. And then you can also plot it, but then the question didn't ask us to plot. And we've already dealt with plotting in the previous video, so yeah, that's just it for I.